Hello everyone, in this lecture we're going to be calculating the formal charge quickly. We have learned how to calculate formal charge using a longer formula, but here I'm going to be talking about how you can get the formal charge right away if you have the structure given. And the formula is going to be the valence electrons minus any electrons you're going to have in the possession when you're looking at that particular structure. So I've got some of these examples. So let's look at this first one where I have OH and I got to figure out what's going to be the formal charge on this oxygen. So what I want to do here, I'll go ahead and draw a circle around the atom that I'm trying to figure out the formal charge. So like this. So when I draw the circle around it, now I want to figure out how many electrons this particular oxygen has in possession at this moment. And obviously your lone pair is going to be in complete control of the oxygen, but when we're looking at the bond, in the bond, you're going to have one electron to one atom and the other electron is going to be to the other atom. That's how you want to think of. Okay, so now I know the electrons in possession and the valence electrons for the oxygen. So let's go ahead and write that down here. So the formal charge is going to be the valence electrons of the oxygen, which is, we know, 6 from the periodic table, minus, now how many electrons we have in possession? Well, we got 2 here, we got 2 here, 2 here, that's 6, and then we got 1 electron coming from the bond. So remember, when you have a bond, the bond made of 2 electrons. 1 electron is going to be to the one atom, and the other electron is going to be belonging to the other atom. So that's how you always want to look at it. Okay, so then we're gonna have here 7 total. So I'm gonna go ahead and write down 6 minus 7. So that's gonna give you an overall of -1 formal charge for this particular oxygen atom. Let's look at this next one here. We got nitrogen. So we're gonna go ahead and draw out the circle around the nitrogen. So this is how it's gonna look like. Okay, we're going to do very similar. We're going to have 2 electrons, 2 lone pairs on the nitrogen, and when it comes to the bonds, we're going to have 1 electron here, 1 electron here that's going to be belonging to the nitrogen, and the other electron of those bonds is going to be to the carbon. So how many electrons I got now? I got 2 here, that's 4, and then I got a 1 from each of those bonds. So that's going to be a total of 6 electrons. And how many nitrogen has? Well, nitrogen has a valence electrons of 5. So I have 6 in possession now, so it's going to be 5 minus 6. So that's going to give you a -1 formal charge. What about this next structure here? So let me just move that a little bit to the left. I'll focus on both of those oxygen atoms momentarily. So let me go ahead and figure out the formal charge on this oxygen atom first. So we'll go ahead and draw the circle around. And then I know this single bond between the carbon and oxygen, I'm going to have 1 bond here, 1 electron here, I'm going to have another electron here. So now figure out how many electrons this oxygen has in possession. So I got 2, 2, 2, that's 6, and then 1 electron coming from the bond. So that's going to be 7 total, so it's going to be 6 minus 7. That's going to give you a formal charge of -1. What about this other oxygen atom? Let's try that as well. I'm going to go ahead and draw the circle around that particular oxygen atoms now. Okay, so then I got 1 electron here. And remember, when you have 2 bonds, so that means that you're going to have a total of 4 electrons. So always keep in mind one bond. In one bond, you're going to have 1 electron to one atom and the other electron to the other atom. The same story with the other one. So one electron to one atom and the other electron to the other atom. So now how many I have in possession? I got 2 here. Those are total, coming from the lone pairs. And then I got 2 coming from these bonds. So I'm going to have um, formal charge on this particular oxygen atom. So still 6 valence electrons on the oxygen. So remember, you're able to look at the valence electrons from the periodic table. Minus how many electrons I have in possession? Well, I got 6 now. So it's going to be 6 minus 6. That's going to give you a formal charge of 0. Okay, let's try these next set here. And it's probably going to be a good idea if you can pause the session and do these on your own and see if those come out to be right. I'm going to try to figure out the formal charge on this central carbon atom. And to do so, I'll go ahead and draw out the circle around it. So when I draw the circle around it, I'm going to have 1 electron coming from each of those bonds. There's no lone pair. All right, so that's just going to be 3 electrons altogether in possession at this moment. And what's going to be the valence electrons for the carbon? Carbon has 4 valence electrons, so it's going to be 4 minus 3, so that's going to give you a +1 formal charge. So whenever you have a +1 formal charge on carbon, it's called a carbocation. What about this next one here? So in the next one, the difference is there is a lone pair on that carbon at the center. So let's see. So same story, I'm going to have 1 electron coming from each of those bonds, and then I got a lone pair, so that's going to be 2, 3, 4, and 5. So I got a total of 5 5 electrons in possession at this carbon. So it's going to be 4 minus 5. That's going to give you a formal charge of -1. And then similarly, I can do this next structure. I didn't really draw out the structure, so sometimes you're actually going to have to figure out how the structure going to look like. So this trimethylamine, where you got the nitrogen to be the central atom, and then you're going to have 3 methyl groups attached to it. And then obviously remember when you draw the Lewis-Dot structure of that, there is going to come out to be a lone pair on the nitrogen atom. Sometimes you will be given the structure and sometimes you will not be given the structure, so you're going to have to figure out the Lewis-Dot structure in that particular case. So if I want to figure out what's going to be the formal charge on this nitrogen, let me go ahead and draw out the circle. All right, so when you draw the circle, now figure out how many electrons I got. So remember, I got 1 electron on each of those bonds. That's going to be belonging to the nitrogen. So now I have 2 coming from the lone pairs, 3, 4, and 5. I got 5 electrons in possession of that nitrogen. So your formal charge is going to be the valence electron, which is 5, minus the electrons in possession, which is still 5. So that's going to give you a formal charge of 0. Okay, what about this polyatomic anion here, which is NO3 1 minus? So to do anything before, you have to actually figure out the Lewis-Dot structure of that. So I'm not gonna go over the details on drawing the Lewis-Dot structure because I expect you guys already know how to draw the Lewis-Dot structures, but I'll go ahead and quickly draw it out, and this is how it's gonna look like. And now my job is to figure out what's going to be the formal charges on every single atom here. And let's start with the top oxygen. So when I draw the circle around the top oxygen, so now I got 2 electrons here, and then 4 electrons in possession from the lone pair, so 2, 4, and then 5 and 6. So we got 6 electrons in possession for that particular oxygen atom. So I will go ahead and do 6 minus 6 because 6 is the valence electrons for the oxygen, so that's going to be 0. Now we've got to do the same thing for the other oxygen atom. So let me change the color here. So this oxygen atom, okay, well, we're going to have 1 bond between the nitrogen and the oxygen, so there is going to be 1 electron belonging to the oxygen and the other electron belonging to the nitrogen. So count how many electrons I got in possession of oxygen. So 2, 4, 6, and 7. So I got 7 in there. So I'll do the formal charge on that would be 6 being the valence electron minus 7 being your electrons in possession. So that's going to give you -1 overall. So that's going to be the same story actually on the other oxygen atom. So I'm not really going to do that because it's in a very same situation. We got 1 bond between the nitrogen and oxygen. We got the same number of valence electrons, same number of lone pairs and everything. So that particular nitrogen oxygen is also going to be -1. This was -1 here, and that was 0 on the top. Now, what about this nitrogen? When we're looking at nitrogen, going to do the same thing. You're going to draw the circle around the nitrogen, and let's see how that's going to look like. So when I draw the circle around nitrogen, figure out how many electrons I got in possession. I got 1 electron coming from each of those bonds, and then obviously in the double bond I have 2 bonds, so it's going to be 2 electrons coming in from those 2 from the double bond. So then the formal charge is going to be the valence electrons of the nitrogen, which is 5, minus however many electrons I got in possession, which is 4. So that's going to give you an overall of +1. So this is how it's going to look like. So when if I redraw it with not too many things on it, and then you can kind of look at it how your net charge works out. So each of the oxygens on the top was 0, the oxygen on the bottoms were -1, and your nitrogen was +1. So when I add up the formal charges of all those up, it's going to come out to be a -1, and that's why you have -1 formal charge on nitrate. So this is a quicker way of calculating the formal charge when you're looking at the structure. Once you do enough practice, you're probably not going to have to write out anything. You will be able to do that in your mind. If you have any questions on any of those, feel free to leave any comments in the section below.